Hi grade 9s, today I'm going to do my second video for you about geometry, and I'm going to teach you the last few terms from page 1 of the geometry booklet. Yesterday we learned the words parallel and we learned the word transversal, and we're going to learn a few rules about parallel lines and transversals today. I'm going to show you pictures of the rules and then we will talk about them together and I will explain them to you. There are some really important rules that we need to learn when we have parallel lines and a transversal. So I'm going to show you one more screen and we're going to talk about that screen together. Okay, so what you'll see when you have two parallel lines and a transversal is that 4 of those angles are exactly the same. So what I've done is I've used some construction paper and I've cut out an angle number 1. And angle number 1 is the same as angle number 4. That actually makes sense because these two right here look like they are opposite because I have the letter X. Also, let's go down here. Angle 5, oh, that's the same as angle number 1 and angle number 4. And also, angle 8 is the same as angle number 5 and angle number 1 and angle number 4. So 4 of those angles are the same, 1, 4, 5, and 8. Now, I want you to notice though, angle 3, however, is not the same, and neither is angle 2. Those angles are different from 1, 4, 5, and 8. So I'm going to get my construction paper and we're going to cut out those angles and we're going to see if we can notice something interesting about those ones as well. So just like the green angle, I've got a purple angle here, and what I can see with the purple angle is that 2 and 3 and 6 and 7 are the same. But notice if I try to put this purple angle at 8 or at 5 or at 4 or at 1, that angle doesn't fit there. It's not equal to those ones. It's only equal to 2, 3, 7, and 6. That means that those 4 angles are all the same. Okay, it looks to me that the 2 angles, when you put them together nicely, it looks like they make a protractor. And what did we learn yesterday about angles that can be put together to make a protractor? We learned that they are supplementary and they add up to 180 degrees. So the most important thing you have to learn today is that when you've got parallel lines, you've got many angles that are equal, many angles that are equal, many angles that are equal, and many other angles that are equal. And if the angles are not equal, then the angles must be supplementary. They must make a protractor, and that means these 2 angles together must add up to 180 degrees. The first rule we want to look at from the booklet is called alternate angles. And just notice I've changed my labeling from 1, 2, 3, 4, 5, 6, 7, 8 to A, B, C, D, E, F, G, H, just because that's what it does in the booklet. And alternate angles tells us that C is equal to F. Let's see if that's true. C is equal to F. That's true. C and F are equal, and we call those angles alternate. Another one that's equal is that D is equal to E. Those are also alternate angles. Now, how can you identify which angles are alternate? Alternate, whenever I was in middle school or grade 9, we called it the Z pattern. Because if you can draw the letter Z like this, then the angles that are inside the Z are alternate and they are equal. 4 and 5, or C and F are equal. And if you draw another Z like this, whether it's forward or backwards, if you draw this Z, then D and E, or 3 and so my phone just rang and interrupted my video, but that last little bit said that if you draw the letter Z using your parallel lines, then 4 and 5, or C and F are equal, or if you draw the Z the other way, 3 and 6, or D and E are equal. That's what we call alternate angles. The next rule we're going to learn is corresponding angles. So corresponding angles tell you that angle A is the same as angle E. It also tells you that angle C is the same as angle G. It tells you that angle B is the same as angle F, and angle D is the same as angle H. Now, back to whenever I was in grade 7 or 8 or 9, we called this the F pattern, because if I use the parallel lines and the transversal to draw the letter F, then the two angles on top of the F, the A and the E, those are equal. The two angles that are underneath the F, the C and the G, those are equal. And if you were drawing your F backwards, the same thing would apply. Drawing my F backwards, the angles on top of the F would be the same, and the angles underneath the F would be the same. So that's corresponding angles. Interior angles on the same side of the transversal. So first of all, here's a transversal. So we're talking about angles that are on the same side of the transversal. So we have to talk about angles over here or angles on that side. Now, interior means on the inside of the parallel lines. So let's find the angles that are on the inside, not on the outside, but on the inside of parallel lines. So here's one. Here's one. Both of these angles are inside, so interior to the parallel lines, and they're both on the same side of the transversal. Now, these angles are not the same. The purple and the green are not the same, but when we put them together, they make a protractor, and we know that when we can draw a protractor, the angles are supplementary and they add up to 180 degrees. It's the same thing on the other side of the transversal. The two interior angles, I've got this one and I've got this one. They're both interior, inside of the parallel lines on the same side of the transversal. They're clearly different, but when I put them together, they make a protractor, and therefore they're supplementary, and they add up to 180 degrees. So that is a little different from the first two rules, because this time the angles are not the same, but they are indeed supplementary. So let's look at an example together where we need to use our three rules: alternate, corresponding, and interior angles on the same side of the transversal to solve a problem. Here's the question that we're going to do together. This is the question we're going to do together, and we're going to go back to the parallel lines and transversal we were using before to help us solve it. So here we have 115. Let's see where that would be located on our original parallel line and transversal. So if I were to use this, that means angle 3 or angle D is in the same spot as the 115. And we want to find the two angles down here. So I know that this is 115 in my example. I want to find the 5 and the 6. So let's use our pieces. So this would be the angle that was 115. We want to find this one and this one. So of those two angles, which one is equal to the purple? Well, I can see that this one down here is exactly the same. They both are the same. So if this is 115, this is also 115, and we call those angles alternate. So in my picture here, this is 115, and y would also be 115. Now, let's look at the x. So let's go back to my original parallel line and transversal. So here's my 115. If I look at the angle underneath it, is this angle the same? Well, no, clearly not. So that must mean it's the green angle. So if it's the green angle, it means those two angles are different. These two angles are different, but we know that when they're different, they still make a protractor, so they add up to 180 degrees. That means over here that 115 plus x has to equal to 180 degrees because they're supplementary. I'm going to minus 115, minus 115. So my x is going to be equal to 180 minus 115, which I believe is 65 degrees. So this one right here is 65 degrees because these are interior angles on the same side of the transversal, so they are supplementary. They add up to 180, and these two are alternate, so they are equal. Okay, so let's try another question because the more we practice this, the better we'll get at it. I'm going to show you another question from the trigonometry booklet. So here is the next question. I've drawn it on my table. So again, we want to refer to our original parallel lines and transversal to help us solve it. So we have 48. It's at the top, it's underneath the parallel line, and it's on the right side. So let's go over here. That's in the same place that 4 is. So let's put that angle right here. And we want to find the two angles that are underneath it. We want to find these two. Okay, well, we can see by observation that this and this should be the same. That means 48 and A should be the same. Those two are alternate because they make the letter Z. So I know over here, my A is going to be 48 degrees. Now, okay, so my 48, let's look back here. My 48 would be up here. We want to find the one that's beneath it. Clearly, these two are not the same. They're both inside the parallel lines on the same side of the transversal, so they make a protractor, so which means they add up to 180. So that means to find my B, I know that 48 degrees plus B adds up to 180. So B is 180 minus 48. And I believe that that means that B is equal to 132 degrees. And if I wanted to check, I just need to add those two numbers with my calculator and make sure they add up to 180. Okay, we've done 2 questions. Let's try another one. So let's look at this question. This question is a little different because this time the parallel lines look like they're going down instead of across. That's not a big deal. All I'm going to do is turn my body around and look at it differently. Okay, so now I've got 134 up here, and I want to know what this angle is right here. Now, if you remember, we talked about the letter F, making the letter F. And we talked about how this angle and this angle should be the same. If this is 134, then this over here should be 134. Let me show you with my original parallel line and my transversal. I'm going to go over my table, over my coffee and my breakfast plate. Here we go. So I have, I'm trying to see here. Oh, okay. I have this one on top. And this one is also on top. If they're both on top of the letter F, then they are both going to be the